Hi everyone. So today we're going to be talking about key features of graphs. And when I talk about key features of graphs, I'm just talking about like the x-intercepts, where the max and min are, where it's increasing, where it's decreasing, things like that. We're also going to talk about how to find the average rate of change of a function. And that's just a fancy way of saying slope, but we'll do that in a second. We're going to start with some of these key features. So the key features that we're going to find are, for each graph, are the maximum. And the maximum is the highest point of the graph. Then we're going to find the minimum, and it's opposite, so it's the lowest point of the graph. Then we're also going to find the x-intercepts, and the x-intercepts are where they cross the x-axis, or where the graph crosses the x-axis. Then we're going to find where the graphs are increasing, so where the slope is positive, and then where the graphs are decreasing, where the slope is negative. Now, when we talk about maximum, minimum, and intercepts, all of these things are a point. So we're going to label it like x comma y. When we talk about increasing and decreasing, these are intervals. And so it looks like a point, but it'll actually be like a range of x values where it's increasing, and then a range of x values where it's decreasing. So let's just go through and start the first example. I'm going to try and draw this graph the best that I can. Let's see. All right, so here's the graph. And we're going to start with maximum and minimum. So our maximum in this case is the highest point. Maximum is the highest point. Now, you can tell that the graph is increasing on both sides, and so actually the highest point would be infinity, but we're talking about the relative maximum, which is the highest point that we can actually see, which would be this point right here. And that point is 1, 0. So our maximum, let's try that again. It's 0, 1. Because your x value is 0, but your y value is 1. Now let's go for the minimum. In this case, you have two minimums. One is right here, and then one is right here. Now, these don't land on like a coordinate point necessarily, so we just kind of have to approximate, and I want you to try and approximate to the closest tenth. So based on your guys' graph, because my graph, obviously I hand drew, I think the left minimum would be at negative 1.2 comma negative 1.1. And then the right minimum, because they're both at the same place, like they're both low enough that they're considered minimums. And so in the right one, it'd be positive 1.2, and then, it's negative 1.1. So all I did was change the sign on the x value. Okay, now let's go through the x-intercepts. And the x-intercepts are where it crosses the x-axis. It crosses the x-axis, in this case, 4 times. So I'm going to start from the very left. The very left one looks maybe like it's negative 1.7. And it'll be comma 0, because that's the point. The y value is 0. And then maybe negative 0.8, comma 0 for the next one to the right. Then the next one to the right, because of the way that this is shaped, I'm going to assume that it's positive. I'm going to assume that it's just the positive versions of both of these things. So 0.8, comma 0, and then positive 1.7, comma 0. So those are all of your x-intercepts, because that's where it crosses the x-axis. Okay, now we're almost done. We're going to talk about increasing and decreasing. So where it's increasing is where it has a positive slope. there's two sections where it has a positive slope, and I'm going to show you with a different color. So right here it has a positive slope, and then right here it has a positive slope. So what we're going to do is write intervals where it has a positive slope. So what I want to see is like, this point right here, from the lowest point to the highest point right here. That would be one interval. So on your guys' graph, it looks like maybe it would be negative 1.2 for my x value for that lowest point. And then the highest point, we know the x value is 0. So it's increasing from where x is negative 1.2 to where x is 0. Then we're going to do the same thing for this other blue section where it's increasing. So the lowest point right there is positive 1.2. So we're going to say 1.2 comma, and then it just keeps on going up and up and up. So the highest point actually has an arrow, and when it has an arrow, we're going to say that that is infinity, because it's just going to continue to increase and increase and increase. So it's increasing where x is negative 1.2 to where x is 0, and then it's increasing from where x is 1.2 to where x is infinity. Okay, now we're going to talk about decreasing. So decreasing is just the opposite. So basically we just want to take the other ones, or the other sections, and I'll label those in red. So the red is where it's decreasing. And if you notice, the last time when we were talking about increasing, I started on the leftmost value and went to the right. I'm going to do the same thing. So I want to start over here and do that chunk first, and then go towards the right. So where it's decreasing, we're going to start with actually negative infinity, because it's continuing, it's like starting at infinity. The x value would go back and back and back, or how do I say this? The x value would continue to go left and left and left because of that arrow. So it's decreasing from negative infinity to that lowest point, which we know is negative 1.2. And then it's also decreasing for this chunk right there. It's decreasing from where x is 0 to where x is 1.2. And there we have it. Those are all of the key features that we're going to be talking about in this self-check. Okay, let's go through another example. So once again, I'm going to try and draw the graph the best that I can. All right, so we've got that line, that line, that line, and here we go. So we're going to start with our maximum. Our maximum is the highest point in the graph. In this case, we don't actually have a maximum. There's no point where it gets really high. They're continuing to increase on the left side and on the right side, but there's no real maximum because there's no point where it like pops up. So what we're going to just say is that there's none. All right, then for the minimum, oh my gosh, I cannot spell, obviously. Minimum. We are going to look at this point right here. And that point's the minimum because that is the lowest point on that portion of the graph. So this graph is considered a rational graph. And let's backtrack and talk about these dotted lines. These dotted lines are called asymptotes. Asymptotes are just where graphs cannot happen or can't be. So these arrows are going to go up and up and up and continue to go up, but they will never cross the dotted line. And then these arrows, like on the left and the right, will continue to go over and over and over and down and down and down, but they'll never cross the line once again. So that's what a rational graph looks like. So when we're talking about maximums and minimums of rational graphs, so you're kind of taking them in chunks. The only minimum, even though the graphs on the left and the right are lower than the graph in the middle, we're going to consider this point right here to be the minimum because that's the only point where it kind of dips down. And so that point right there looks like it might be at 0.3. So that's considered our minimum. Now we're going to do our x-intercepts. So can you see anything where anywhere where it crosses the x-axis? No. These lines on the left and the right get really close to the x-axis, but they never actually cross it. And so this would be a none. All right, now let's talk about increasing and decreasing. So where it's increasing, we're thinking about positive slopes. So it's increasing in this chunk right here, like that's all an increase. And then it's also increasing right here. And so what we're gonna do is same thing, we're gonna find the x values of that. So you start with the left value, or the left chunk, which is that middle chunk. So that's our x value for where it starts is 0. And then it's gonna go up to where this asymptote is, and that's to 3, okay? Then it's also increasing on the right side of that asymptote, so it's going to increase from 3 to infinity. Now the reason why it's increasing to infinity is because this arrow just goes on forever and ever and ever, so it's just going to continue to go climb up and up and up. It's going to get really close to 0, and it's going to continue to get really, really close to 0 by moving up, but it's never going to cross that 0 line. We have to split it up like this, even though like this chunk, there's 2 3s right here and right here. You want to split it up because of that asymptote, because it's not a continuous increase. It's increasing from 0 to 3, and then it's also increasing from 3 to infinity. Our decreasing is going to look super similar to that, because where it's decreasing on the very left side, and then it's also decreasing on the left side of that middle chunk. So when we write it out, we're going to say it's decreasing from negative infinity to negative 3, because that second asymptote, or that asymptote that's on the left, is at negative 3. And then it's also decreasing from negative 3 to 0, because that chunk is the part of the middle section of the graph. And once again, we can't just write it all together because of that asymptote. It's split up, it's not continuous, and so we have to split up the decreasing intervals. Okay, so now we're going to talk about that average rate of change. So average rate of change is just a fancy word for slope. And so the formula for average rate of change is sorry, let me make my pen work. Oh my goodness. F of B minus F of A over B minus A. Now, I told you that it was just a fancy word for slope. This is just a fancy equation for slope. What the questions are going to do is give you a range, and that range is A and B. So like those would be plugged in for your A and B. Now on the top, you have F of B and F of A. What that tells me is that I have to plug in my A and B into the equation that they give me, and then whatever answer I get out is what F of B is or what F of A is. So let's just go through an example. Number 3, the equation is F of X equals 4x squared plus 3. Now, and then it gives me a range from 2 to 5. So what that tells me is that 2 is my A and 5 is my B. So what I'm going to do is I'm going to plug in 2 in for my X and then 5 in for my X to find my F of A and F of B. So F of A is the same thing as saying F of 2, which is the same thing as saying 4 times 2 squared plus 3, which is equal to 19. You can just plug that into a calculator. And F of B is equal to F of 5, which is equal to 4 times 5 squared plus 3, which is equal to 103. And then we know that A is equal to 2 and B is equal to 5. So now all I'm going to do is plug that into this equation. So we start with F of B, which is 103, minus F of A, which is 19, over B minus A, so 5 minus 2. So now all we have to do is the math, and we do 103 minus 19, and we get 84. and then 5 minus 2 is 3, and 84 minus 3, let's see, 84 divided by 3 is equal to 28. And so my average rate of change, or my slope between when that function is 2 and when that function is 5, is 28. Let me kind of show you one cool thing. So 4x squared plus 3 kind of looks like this a little bit. And so when it's, let's see, it would look kind of like this on the graph. So when I ask you to find the average rate of change between 2 and 5, what I'm doing is I'm saying, okay, well, this is where it's 2 and this is where it's 5. So I want to find that slope. And in this case, that slope is 28. Okay, now let's just try one more example. And this example is okay, so f of x equals, sorry, I'm getting ahead of myself, 1 over 3x minus 2. And we want to go between -3 and 0. So again, the first number is going to be my a, the second number is going to be my b. And so if I want to find f of a, I would find f of -3, which means that's 1 over 3 times -3 minus 2, which is equal to -1 over 11. And then f of b equals f of 0, which is 1 over 3 times 0 minus 2, which is -1/2. So when we plug in our values, we're going to have -1/2 minus -1 over 11 all over b minus a, so 0 minus -3. You want to make sure that you put, especially if your answers are negative, put them in parentheses, because we don't want to confuse the negative sign in the equation with the negative sign in your f of b or f of a. Okay, so now we're going to do a little bit of math. We're going to do -1/2 minus -1 over 11, which those two negatives right in the middle will cancel each other out and make a plus sign. So we could write it as -1/2 plus 1 over 11. And I get -9 over 22. And then 0 minus -3, again, those two negatives could cancel out, and we would get 0 plus 3, which is just 3. So then we do -9 divided by 22, all divided by 3. When we do a fraction divided by a whole number like this, what we can do is take this 3 and just multiply it up here. So this is the same thing as saying like -9 over 22 times 3, which is -9 over 66. And that can be simplified to -3 over 22. And so that's my slope. So in that function between 0 and, or -3 and 0, my slope is -3 over 22, which means I go down 3 and over 22 units. And there we have it, key features of graphs and average rates of change.